Welcome to the course on power quality. Today we will start this hybrid power filters. The outline of presentation on hybrid filter is we will start from introduction. We will talk about the state of art on hybrid power filter. We will classify the hybrid power filter. Then we will discuss principle of operation of hybrid power filter. Then we will go to analysis and design of hybrid power filter. Then we will talk about the control of hybrid power filter. Then modeling, simulation and performance of hybrid power filter with some case study. Then we will discuss numerical examples, we will summarize and then the references like. So, coming to the objective of this hybrid power filter, we will talk about first the requirement and its application, their application. We will talk about configuration of these hybrid power filter, talk about control of hybrid power filter, analysis and design of hybrid power filter, then method of modeling and control of hybrid power filter. So, now coming to typically with the introduction of with the power quality problem in distribution system, we have typically of both voltage quality problems, especially harmonics, and the current power quality problems, especially the harmonics in the current. So, we have a harmonics in the voltage and harmonics in the current, and that is the reason we have to use the filter, and typically the hybrid filters is supposed to eliminate the harmonics like but we can do additional job, but at the cost of additional rating like So, what really have this power quality problem causes? The increased RMS supply current, it causes the increased losses and low system efficiency, then it has a poor power factor, then poor utilization of distribution system, then we have a heating of components of distribution system, and then derating of the distribution system like. Then coming to power quality problem in distribution still, the distortion in voltage waveform, the interference to communication system, disturbance to nearby consumers, and the single solution to these problems is the hybrid power filter of, or we call it a universal active power filter, and it is a combination of active shunt power filter and active series filter, and sometimes we use the passive power filter along with the small rating active series filter, and these are the typical the photograph from the industry like Hortium hybrid power filter they are manufacturing, and then the shunt active power filter component are of universal active power filter provides harmonics current elimination, then the reactive power compensation along with the load volt balancing, neutral current compensation, and the series active power filter component of universal active power filter keeps the load and voltage insensitive to the supply voltage quality problems such as harmonics with the voltage harmonics, voltage sag swell, voltage surges, voltage spike, voltage notches and voltage unbalance. So, that is about what series active filter part does it. And of course, this as far as development are concerned of this hybrid filter, they are developed in varying configurations. They use the advanced control techniques and the different solid state devices. They use the of course advanced sensors like Hall effect voltage and current sensor, and they use the microcontroller and DSP to implement the control algorithm like, and these are typically Hall effect like a current sensors, and this is the kind of DSP board on which these algorithms are implemented through proper software and with the feedback like. So, coming to the classification of hybrid power filter, we can classify it in many categories. So, first category is like a converter type, whether we are using current source converter bridge structure or we are using voltage source converter bridge structure, and that is first configuration. Second is the topology configuration, the combination of active series and active shunt power filter or combination of active series and passive filter, that is we have that kind of you can call it like configuration. Another is supply based classification, like might be using this as a single phase hybrid filter with a 2 wire system or 3 phase 3 wire system or 4 wire 3 phase system like. So, now coming to the classification of hybrid filter for power quality improvement, if we classified here hybrid filter, we have a single phase, we can have a hybrid of passive, we can have a hybrid of passive active filter, we can have a hybrid of active filter. Similarly, coming to the hybrid filter of 3 phase 3 wire, so we can have again the hybrid of passive filter or hybrid of passive active filter and hybrid of active filter. And coming to the third category on supply based system like a 3-phase 4 wire. We can have a again typically of combination of passive filter and passive active filter or combination of active filter. So, these are the typical classification of hybrid filter. And now coming to the hybrid filter as a combination as a circuit configuration, we say combination of passive you can call it like a passive series and passive shunt filter. So, we have a here you can call it the passive series and we have a passive shunt, and this is considered quite good topology in a sense that you are having a shunt filter in parallel to the load. Normally, the load which are of current fed kind, we have this kind of configuration and we have a shunt passive filter. So, well, the drawback of this passive series is taken care by the passive shunt and the drawback of passive shunt is taken care by passive series. What is the drawback of passive series? It behaves as an inductor when connected in series with the line. So, the shunt filter at fundamental frequency behave as a capacitor. So, it give a capacitive reactive power which can compensate the inductive drop of series filter. But what is the drawback of shunt filter? Because it can have a resonance with the supply system. So, this passive series filter can block the resonance if it is a tendency of shunt filter. So, this comes to be as a quite good combination of hybrid of passive filter. You can have a of course, the hybrid of series on the load side and shunt on grid side. Of course, maybe in some situation with the voltage fed load maybe it can be taken up, but it is not really very kind of popular, but of course, some situations. So, but of course, it is also a hybrid of 2 passive filter, or you can have a hybrid of 2 passive series on the load side, series on the grid side and then passive shunt in between like a T network, or you can have a pi network with the 3 element 3 passive filters like. Of course, they are used for reducing the rating, or you can use a passive series filter along with the active series filter to avoid the drawback of this passive series filter. Hardly you can have a very 3 to 4%, 5% active series filter. So, that the major burden goes to typically of your passive filter, or you can have a this active filter in parallel to this passive filter we take care of the control or making passive filter more effective like and this is another like you can have a passive in series and then active filter in shunt, or you can have a both in parallel passive shunt and passive series. In this case you can reduce the major rating can go to passive shunt, small rating can go active shunt, and the drawback of passive shunt can be eliminated like. This is another very popular configuration like we have a passive filter to avoid the resonance as well as making effective we put a small series active filter, maybe not more than 4 to 5%, 95% burden goes to passive shunt filter. Well, why this topology become very popular in the sense because the cost was very high of active filters. So, here active filter rating is reduced to quite low and major burden goes to passive filter and becomes effective. So, drawback of passive filter especially shunt filter like a resonance fixed compensation that is also avoided in this case up to some extent, or you can have a shunt on the load side and series passive filter in the line, or you can have a this is also another very popular topology where passive shunt is on the load side and normally used with the current fed kind of load, and you have a active small rating active series filter which not only avoid the resonance or the drawback of passive shunt filter, but it can make a effective like absolute solution of this passive filter by injecting a harmonic voltage across the passive filter as much as it takes the entire harmonic currents of nonlinear load, and the harmonic currents in the supply can be made almost negligible like. So, that both the drawback can be taken care. So, this has become again quite popular in the sense because 95% almost like goes to the burden on passive shunt filter, only 5%, 3 to 4% remain only active series filter like. So, or you can have like a passive shunt and in series you can have a small active filter, or you can have a here the passive and then a small series active filter, or you can have a typically a combination of 2 passive in parallel to this, or you can have a parallel to passive and then shunt on this side, or 2 passive and then shunt, and then you can have a both passive and then small active filter to avoid the drawback of this. So, or you can have a series passive filter with the voltage fed kind of load, and you have a small passive active filter in series with the passive to reduce the rating virtually of active part also, or you can have this kind of network with the passive active series with the with the passive and other passive in parallel, or you can have a passive shunt active shunt and with the passive shunt and then series, I mean like, and then active and then 2 passive, or you have a small active here and passive here as well as passive. So, that you can further reduce the rating of this. So, there are plenty of topology, then you can have active and passive on both the side, or you can have active in series with then passive here, and then you can have a like a 2 passive and shunt passive in series with the small active, and or you can have a small active 2 passive. So, or you can have a active in parallel to passive, or you can have a small passive, a major passive, a small passive in with the parallel of active also, or 2 active with the 1 passive, or 2 active with 1 passive in this configuration, or 2 active with passive here, or you can have active shunt with the passive, or you can have a 2 active series with the passive shunt, or you can have a active series with the active shunt, but with passive here. So, that rating are reduced like, or you can have a 2 active with this passive here, then active shunt with this, and then its active series, that is for voltage fed kind of, and this can be like to make the passive filter effective, or 2 active with 1 passive, or 2 active again with another configuration of putting series on this side, or you can have active shunt with the series passive also, and 2 active with the passive, and shunt mainly with a small series, and then you have a small series and a small shunt here also, or 2 shunt with the passive major shunt, or a passive shunt here, and the 2 active shunt and series. I mean, this is the active shunt with the current source, and this is the voltage source within parallel to passive, or 2 active with this configuration to reduce the rating virtually of passive active filter, or this we call like very a good combination which we call active series and active shunt, what we consider earlier like a universal active filter, both the shunt like, I mean, and we can say similar to like we discussed it in UPQC earlier. So, that is also very good configuration, or other way around, active series can be this there, and but this configuration is more popular than compared to that like, or you can have a 3 active filter, 2 series and 1 shunt, or 1 series and 2 shunt in this manner, or you can have a 2 shunt with a small passive also. So, you can find so many combination of, typically you can call it like a your habit filter like of different variety. So, coming to principle of operation of this hybrid passive filter, I mean like the principal operation of hybrid filter is the main objective of hybrid filters are to mitigate the multiple power quality problems of nonlinear load and or supply system depending upon the requirement from the combination of couple of passive filter to couple of active filter, and in hybrid filter mitigates most of the power quality problem for satisfactory operation of the consumer equipment even in the cases of polluted supply system. At the same time, if hybrid filter provides the mitigation of most of the voltage based power quality problem and current based power quality problem present in the consumer loads or otherwise in the supply system, and it results sinusoidal balance current supply current in the supply. Here the basic principle of most prominently used 4-wire topology is given here in detail. So, you can think about like what the, I mean here it is a 2 passive filter, series and shunt. So, this is the passive series and this is the passive shunt, and of course, we look into this interesting topology which of course, we design, we develop it and we patented it also, and it really will give very good performance. So, what we can say, this is shunt and this is series. So, series takes the drawback of shunt, because shunt might have a two drawback. One is the resonance problem. So, series mitigate the resonance because it's avoid the lower order harmonic it blocks from here, but it behave as an inductor at fundamental frequency, and this give a capacitive reactive power which compensate for that reactive power taken this. So, by proper design we are able to maintain the voltage at the point of common coupling within a certain range. So, that it's not load is not affected, and we are putting shunt so that I mean there is no problem of that. So, I mean it takes care at unity power factor on supply by proper design. So, we look into the design properly, and the passive series and passive shunt based hybrid power filter offers excellent performance for harmonic compensation of voltage fed nonlinear load, and the passive shunt filter suffers from inherent problem of series and parallel resonance with distribution network component and fixed compensation. Moreover, their application is considered inadequate for the voltage fed kind of harmonic producing load like a diode rectifier for fed variable frequency type, and their compensation characteristic has been dominated by unknown source impedance which poses serious problem in their design. So, on the other hand, a series passive filter has been found suitable for voltage fed kind of harmonic producing load, but suffers heavily on account of poor voltage regulation at the point of common coupling and poor power factor throughout its range of operation. Therefore, a hybrid passive filter provides a harmonic compensation at par with the active filter, which design is sensitive to source impedance, eliminate the chances of resonance over the wide spectra and reduces the large variation of power factor and terminal voltage with varying such rectifier type of non-linear load. And beside this topology also helps in fast settling of the transient and blocking the harmonics. This passive hybrid filter provides an effective compensation of current harmonics for such voltage fed load with slightly detuned resonant points corresponding to available component value for effective and efficient operation under varying load condition. Moreover, the drawbacks of series passive filter behaving as an inductive impedance drop at a fundamental frequency are eliminated by the passive shunt filter, and in addition the drawbacks of shunt passive filter having the resonance with source impedance and fixed compensation are eliminated by passive series filter. And this is typically the quite popular topology. I mean, in this case, I mean, it is a kind of voltage fed. So, we have here non-linear load, but we have a major amount goes to passive filter. We connect in a series with this a small rating 3 to 4% series active filter, so that this avoids the resonance, and the another is it makes the variable harmonic compensation. So, you can inject the typically here a adjustable harmonic voltage in such a manner that this sucks the harmonics current, entire harmonics current or all the harmonics current of the load, and becomes quite effective. Like the reason why it, I can tell you why it has become quite popular. I mean, people develop active filter, but they were very costly, but passive filter having sub drawback. So, with a small active filter with proper control, we are able to eliminate the problems of your passive filter and become a quite effective solution with a cost effective solution as well as the very effective for compensation also. So, the passive shunt and active series hybrid filter provides the typically for harmonic compensation of voltage fed non-linear load as well as cost effective and adjustable solution for eliminating the current harmonic. This hybrid filter is formed by series connection of passive shunt and a small capacity active filter. The passive filter suppresses harmonic current produced by the load, whereas the active filter improves the filtering characteristic of passive filter. As a result, the hybrid filter system can solve the problem of inherent by using only the passive filter. The series connected active filter is controlled to act as a harmonic compensator for the load by constraining all the harmonics current to sink into the passive filter, and this eliminates the possibility of series and parallel resonances. By actively improving the compensation characteristic of the tuned passive filter, the need for precise tuning of passive filters is avoided, and the design of the passive filter becomes insensitive to supply impedance up to some extent. And this topology is also suited for harmonic compensation of load connected to strip supply system, and the active filter element acts as a harmonic voltage source, compensating voltage drop in passive filter at harmonic frequency at PCC, thereby producing a short circuit across the passive filter at harmonic frequency. This hybrid filter provides the elimination of current harmonics and limited supply voltage distortion, since it acts as a harmonic voltage source, compensating the voltage drop in passive filter at the harmonic frequency at PCC. However, the distortion in the supply voltage adds to the required voltage injected, and hence the required rating of active filter may increase. And this is another topology, quite popular topology, that you have a current fed kind of load, thyristor converter may be RL load, it may be DC drive, or it can be deriving a current source for your large rating synchronous motor drive. There are plenty of load of such nature, or maybe like as you. So, major amount you are putting like a passive filter here, like 4, and you are not disturbing the current fed kind of load because you are connecting in shunt. Now, this series active filter is making this passive filter more effective by injecting appropriate voltage here, so that you are able to force the entire harmonic current required by the load into this passive filter. And moreover, it avoids the resonance also, and the rating of this active filter is hardly, reported 4 to 5% only. So, the 95% rating goes to passive filter. In the country like developing country, we are able to get manufactured very well passive filter, but the major problem, large rating active filter was not cost effective, and by putting a small rating 5% of active series filter, all the drawbacks of passive shunt filter is eliminated. One is the resonance, and another is it is able to make adjustable solution for harmonic compensation, because you can push the different harmonic current into passive filter by generating a different magnitude of harmonic voltage at the point of common coupling, which the harmonics load needs here. So, then in that case you can reduce the harmonic current to supply to a great extent, quite low value, because this harmonic voltage you can generate any amount by series small rating, not very large amount of voltage you require, very small, because this we have at harmonic frequency almost quite low impedance. So, you require a small harmonic voltage to suck very large harmonic current into this passive filter like. So, this topology is quite cost effective as well as considered to be quite good, in a manner for such kind of voltage fed kind of load. So, active series and passive shunt based hybrid filter provides a cost effective and practical harmonic compensation solution by providing harmonic isolation between supply and load, besides the effectively mitigate the problems of both passive filters and pure active filter. And the combination of low cost of passive filters and control capability of a small rating active filter effectively improve the compensation characteristic of passive filter and hence reduces the rating of active filters less than 5% compared to the pure shunt or series active filters. The passive filter suppresses the harmonic currents produced by the load, whereas the active filter improves the filtering characteristic of the passive filter. As a result, the hybrid filter system can solve the problem of inherent in using only the passive filter. The series connected active filter is controlled to act as an harmonic compensator for the load by constraining all the harmonic current to sink into the passive filter, and this eliminates the possibility of series and parallel resonances. Well, this is the typically a series, active series and passive shunt filter, which can be effectively used for any kind of non-linear load. This is similar to like what we discussed in UPQC earlier, but of course, in UPQC we did not discuss the harmonics. So, the load there we consider linear load, here we have a non-linear load which may require reactive power and harmonics, and supply might have also the voltage distortion, voltage harmonics. So, series filter will take care of that and shunt filter will take care of the typically of current harmonics and load unbalance, all the along with the harmonics, actually the filter is supposed to take care of harmonics, but you can do additional tasks also what we discussed in DStatCom like load balancing, negative sequence compensation, neutral current compensation, as well as you can take care of even a typically even the voltage regulation. So, all those things can be taken care by universal filter, we call it universal filter because it have a active series and active shunt, and DC link is shared between the two, and regulation of DC link voltage is the responsibility of series active filter. Whatever the active power this series active filter needs, that shunt should provide for bidirectional power flow for active power. So, in general this hybrid filter known as universal active filter has two voltage source converter connected to the common DC bus. One voltage source converter is connected in series and known as a series active power filter of AC line through an injection transformer, and another VSC is connected in shunt known as a shunt active power filter normally connected across the consumer load or across the point of common coupling. Both the voltage source converter use the pendulum control, therefore, they require a small rating ripple filter to mitigate the switching ripple, and it requires of course the Hall effect voltage sensor and current sensor for feedback signal, and normally a digital signal processor is used to implement the required control algorithm to generate the gating signal for the solid state devices of both voltage source converter of universal active power filter, and the series voltage source converter is used as a series active series filter and normally denoted AFSS is controlled in pendulum voltage control mode to inject the appropriate voltage in series with the AC main, and the shunt voltage source converter used as a active shunt filter, we call it AFSH filter, is normally controlled in pendulum current control mode to inject the appropriate current in parallel with the load in the system. And this universal active power filter is considered as a perfect solution for elimination of voltage harmonics at the point of common coupling and current harmonics produced by non-linear load. It also capable of providing the compensation of other voltage and current based power quality problem, but at the cost of additional rating and an increased cost. So, coming to like a typically an analysis and design of hybrid power filter, typically a topology which is quite popular, which mention it that you have passive filter, in series we have active filter and we have a non-linear load. So, since consider configuration of hybrid filter consists of passive filter along with a small rating active filter, therefore, the design consists of both the component, and design procedure is adopted to design a passive filter for a voltage fed load consisting of diode rectifier with a filter capacitor and equivalent load of 25 kilowatt of at 415 volt 3 phase 50 hertz supply. And passive filter basically consists of a series combination of an inductor and capacitor tuned at a particular frequency and act as a low impedance path for that harmonic. And the fifth and seventh harmonic filters are designed using a series tuned filter, and high pass filter is designed using a second order damped filter. The design procedure of series tuned passive filter is explained on the voltage fed consisting load of diode rectifier with a filter capacitor, the equivalent resistive load of 25 kilowatt 415 3 phase 50 hertz supply system, and the voltage rating of series active filter is obtained from the difference of PCC voltage and load voltage. Hence, the series active filter is calculated as Cn QC upon MV omega Vs square, and the trap for nth harmonic current, the inductance order of calculated Nn equal to Ni square N square Cn. The capacitance is calculated from reactive power and inductor is calculated from this tuned relation of for a particular harmonic, and the series resistance for inductor nth order is calculated from quality factor, that is Rn equal to N omega n upon Qn, and Qn is the quality factor of inductor of nth order harmonic, which is normally considered between 30 to 100. And in the design of second order damped filter, the filter parameters CH, LH and RH are calculated. However, the next dominant harmonic is considered as the next value for N for high pass filter, and quality factor QH for the high pass filter inductor is considered between 0.5 to 5. And the active filter is only a small rating order of 5% of the load rating. Moreover, this small rating active series filter is designed using the same procedure given earlier with the series filter. We discussed it last lecture, and in addition there are several numerical examples are listed on different topology of hybrid power filter consisting of such small rating series active filter. So, coming to the design of active shunt filter, the active shunt filter we discussed already in the procedure as earlier in earlier section. In addition, there are several numerical examples illustrated on different topology of universal active power filter consisting of such active filter. So, coming to the part of control of hybrid power filter, I mean the control of this passive with a small series active filter. So, the main objective of control algorithm of hybrid passive filter is to estimate the reference voltage of or reference current using feedback signal depending upon their application, and reference voltage or currents for the control of series active filter power filter have to be derived accordingly, and these signal may be estimated using a number of control algorithms. There are many control algorithms reported in the literature for the control of series active filter, which are classified as time domain and frequency domain algorithm, and there are more than couple of dozen of time domain and frequency domain control algorithms which are used for control of series active filter. And these control algorithms are explained in previous chapter, which we have easily modified the control for series active power filter. And this is the typical example of that we are sensing supply voltage, we are sensing supply current, and we are using a Clark transformation. This is basically instantaneous active power theory for control of hybrid filter. So, we calculate the supply power, active power, reactive power, and it consists of course the ripple and fundamental. So, passing through high pass filter, we can take only the kind of only the ripple here. So, and then we have a DC link voltage regulation from this. So, we get the small active power, reactive power, because it is in series with that. So, we have a P and Q. Once we know P Q, we can calculate like a supply harmonic current, and from this sensing typically, I mean here the sense with the gain, we are able to inject the voltage in series with the this kind of passive filter like. So, that becomes a very simple control. So, in this hybrid filter configuration, 3 phase supply current are sensed and their harmonic currents are estimated using as IRPT algorithm adopted for conventional active filter. But instead of load current, supply current also are sensed, and the process using instantaneous active power theory based control algorithm, and 3 phase filtered supply voltage are transformed into 2 phase alpha beta coordinate as typically from VABC to V alpha beta, and similarly 3 phase currents supply current are transformed into 2Q alpha beta from supply current to 2 alpha beta component, and then we calculate the instantaneous active and reactive power typically from this relation, which consists AC and DC component, DC and AC component, and of course out of this is taking component, typically these are and these are AC component. So, in these expression the fundamental load power is transformed to DC component, and the distortion or negative sequence are transformed to AC component. So, AC components of active and reactive power are extracted by using a two high pass filters, and in addition the active power filter regulates the DC capacitor voltage without any external power supply. So, if the active power filter outputs at the fundamental voltage that is in phase with the fundamental leading current of the passive filter, the active power formed by the leading current and the fundamental voltage is supplied to the DC capacitor. Therefore, electrical quantity to be controlled in a DC voltage of active filter feedback loop is added to the reactive power. So, for building up the DC voltage of active power filter, the error between the sense DC voltage and the reference DC voltage is given to PI controller, that is the error, and the output of PI controller is added to AC component of instrument. This is the output of PI controller of DC link and reference power of the harmonic currents are estimated typically from these relation, and where we have added this output of PI controller for reactive power. So, reference 3 phase harmonic currents are estimated as typically from this P and Q what we estimated from this reverse transformation, and now we put a estimated harmonic current in each phase with a gain of K, and we put virtually kind of impedance in series voltage with the K into ISH, and the gating signal are generated by comparing the reference voltage with triangular carrier wave or so. So, that is about the control of this. So, coming to a control of hybrid using indirect current control, and this is what we have here. We are sensing supply current, we are estimating fundamental out of it, and then we are taking same here, but of course, we regulate the DC link voltage with the we take a low pass filter because DC component is there, then we put a PI controller, then that we consider as a gain, and we multiplied this gain with the typically from fundamental one, and then we add with this. So, that get the virtually added gain. So, we get the fundamental current, and then we virtually along with the sense current we are able to get the gating signal for hysteresis current controller for this indirect current control. So, in this control algorithm the computational delay and number of sensors are reduced than the instantaneous reactive power theory by indirectly controlling the 3 phase supply current, and in this control algorithm the 3 phase supply current are sensed and their fundamental component are estimated with a similar algorithm adopted for active power filter control using synchronous reference frame theory. And synchronous reference frame theory isolated extract the fundamental positive sequence component of supply current by transformation SA into DQ reference frame. So, here we are using supply current into alpha beta and from alpha beta to DQ from typically from the part transformation, and DC instance transform supply current component are extracted using the 2 low pass filter with a cutoff frequency of around 9 to 25 hertz, and the fundamental frequency of supply current is extracted using inverse Park transformation. So, we get typically here from DQ to alpha beta and fundamental alpha beta, and from alpha beta to 3 phase fundamental current, and the DC voltage DC link voltage DC bus voltage control of active filter achieved using a PI control. Low pass filter is required to filter ripple in the feedback path of DC bus voltage. The output of DC bus voltage represented as a gain, and the reference signal for current control is given by typically by gain into this fundamental current which added into here, and this gives the reference grid current. So, 3 phase supply current are controlled to follow the reference fundamental positive sequence current by switching the VSC through the hysteresis current controller, which results in an indirect current control also. So, can we stop here?